Okay, good morning. So this is our skeletal system, lecture 3. We've already gone over functions of the skeletal system, an introduction to it, bone remodeling and growth, the anatomy of a long bone, and classification of bones and organization of the skeletal system, as well as the bones of the skull. So today we're going to go over the bones of the vertebral column and the bones of the thoracic cage, so the rib cage. So we're starting here with the vertebral column. So basically this is part of the axial skeleton because it runs up the center of the body. It goes from the base of the skull down to the pelvis, but it does not include the pelvis or the skull. Its purpose is to provide support for your head and for your trunk, what allows you to stand up straight. And also, it protects your spinal cord, which is the second most well-protected organ in your body after the brain, of course, which is completely surrounded by the skull. The spinal cord, there's a picture on the next slide. The spinal cord actually runs through the foramen of each vertebra. But it is exposed a little bit because nerves have to run out of it to reach and innervate the entire body. The spinal cord is part of the central nervous system, so it's an extremely important organ. If it is injured or damaged, that leads to paralysis, either partial or total, in the rest of the body. So the components of it, it's not just bone here. You do have the vertebrae. AE means it's plural. So you have vertebrae, but the vertebrae don't touch directly. If they did, that would be very painful. You wouldn't be able to move, basically. Instead, they're separated by these discs. They're made of fibrocartilage, and there's one disc in between every vertebrae, like in between it and the next one. And that's for cushioning, to protect against friction, things like that. However, humans, it's just a part of being human. We tend to get back problems when we get older. And one of the problems is discs that get swollen or herniated, where they kind of bulge out or slip out. And when that happens, those can put pressure on your spinal cord or on your nerves, and then that can cause problems. A common one is when you have a herniated disc in your lower back, puts pressure on your sciatic nerve, and then it hurts, like in your feet. It hurts to walk or to stand. So in addition to those two, the vertebrae themselves are connected to one another through ligaments. They run up and down the spine. That helps the vertebrae to articulate with one another, and that gives you the ability to move your spine. You can stretch up or kind of scrunch down or twist or bend from side to side. So on the bottom here, a single vertebra has a lot of different structures on it. It is an irregular bone. It's not part of our curriculum that you know all these structures, but they're there for you. Just basically, the foramen is the big hole in the middle where the spinal cord goes, and all the spiny processes are basically the little pokey things that run out of the back of the spine. If you've ever touched someone on their back or reach around and touch your own in the middle, the part that you feel in the very center are these spinous processes. And so here's a picture what the vertebral column would look like. This is a posterior view, and this is lateral. So if you're kind of looking at the side, you can see there's curvatures that are supposed to be there. They help to give your spine strength and support. And then on the right side, it looks a little bit more straight, but you can see more clearly. We classify the vertebrae into different areas based on where they're located, and then also their size and shape. If you look at the cervical vertebra versus thoracic, you can see the thoracic have these processes, these pokey parts pointing off to the side, whereas the cervical vertebrae don't really have those. So the cervical vertebra, the cervical region, if you remember way back to chapter 1, is the neck area. So these are the vertebrae that are located in your neck. You have 7 of them. These bones help to support your head. They, allow your neck to move and bend and twist as well. They are unique compared to the other vertebra. They have what they call transverse foramina, meaning they have more than just that one hole. There's a picture coming up. Well, let me go to it right now. So the other vertebra, they all have this hole in the middle called the foramen, the vertebral foramen right here. Everyone has this because this is where the spinal cord will go, and this is a transverse view, a top-down view. But the cervical vertebrae have 2 other foramens, okay, 2 little holes. Those aren't found on the thoracic or the lumbar vertebra. Okay. And these are so you have major blood vessels that go through them that supply your brain with oxygen. It's very important that you get that so you don't die. They also have some other processes that are extra, and they are unique in shape. Now, there are 2 that are special, and you do need to know them when it comes time for your test. You need to know their names. The very first vertebra, the one at the top, is called the atlas, and it's named that after the Greek myth, how Atlas held up the world on his shoulders. So it's named that because this vertebra holds up the head. It is special, and it articulates with the second vertebra called the axis. And it's a special, it's called a pivot joint. We'll be getting to that at the end of the chapter, but that's what allows you to turn your head side to side like you're shaking your head. No, the other vertebrae don't have that ability. You can kind of bend and stretch, but one vertebra does not rotate around another. It's only the atlas that rotates around the axis, and it's called the axis because it's the same term as in math or like in engineering when you turn something around its axis. And so we've seen this one. So here are the atlas and the axis kind of separated out. So you could see this part is different. This is the articulation point. This on the atlas forms the joint with the axis. Okay, it has a little like knobby protrusion. You can see it better there. Okay, and then this slides over it, and then it can rotate round. Next are the thoracic vertebra. Thoracic is the adjective. The area of the rib cage is called the thorax. Maybe you remember that from elementary school when you learn the parts of an insect, the head, the thorax, and the abdomen. These are the thoracic vertebrae. And these vertebrae articulate with the ribs, meaning they make a joint with the ribs in the back. Because of this, these vertebrae have to be bigger and stronger than the cervical vertebra because they form another joint. They have slightly different, processes and facets. And they're larger, like thicker, because the further down the spine you go, the more weight each vertebra is holding because it's holding everything above that up against gravity. If you were going into medical school, say you wanted to be a doctor, you would have to actually learn to identify each separate vertebra. There's 24 that are separate, not counting the sacrum and the coccyx. So you'd have, they'd pull one out of a bag and you'd have to say, oh, okay, I know this one's the atlas, or I know this one's the 10th thoracic vertebra. But that's, if you're going into the medical field. For this class, you don't have to know that in depth. And here's a picture so you can see the spinous and the transverse processes are much larger than they were in the cervical vertebrae. Next are the lumbar vertebrae. So these are in the lumbar region, the lower back. You have 5 of them. And they have to be even larger and stronger because they're supporting even more weight. So they're supporting the abdomen, the thorax, the rib cage, the neck, the head. And all of their adaptations are for weight bearing. Now you do need to know how many vertebrae are in each section. So let me grab a pen here. So basically there's a mnemonic device for you to remember. So it's 7, 12, and 5. So think about these as the times of the day when you eat. So 7 o'clock is when, well, if you're not at high school, at 7 o'clock you would normally eat breakfast. And 12 o'clock is, whoops, that's noon. That's when you would eat lunch. And then 5 o'clock is when you would eat dinner. Okay, so think about like the standard meal times, and then that goes with the cervical. So you have 7 cervical vertebrae. Lunch would be the thoracic vertebrae. And then dinner would be the lumbar vertebrae. Okay, and then here's a picture of a lumbar vertebrae. Okay, so if you look, its processes are shorter, a little thicker, but its body is bigger and thicker. All right. Moving inferiorly, next we have the sacrum and the coccyx. These are part of the vertebral column as well, but they're actually made of fused vertebrae. So they start as individual bones, but then as fetal development proceeds, they fuse together. So the sacrum, sometimes we call it your butt bone. It's not really a part of your butt. It's technically in your lower back still, but it's kind of got a triangular shape. And it is consisting of 5 vertebrae that were fused together. And here's a picture of it. You can see that this top part is the sacrum. Okay, and here's the anterior and posterior view, so you can kind of see the back of it. So if you've ever fallen real hard on your rear end and you're sore because you landed on your bone, it's because maybe you bruised your sacrum. Now the coccyx is at the bottom, okay, down here. And sometimes we call this your tailbone. It's not an actual tail, but we just call it that. And sometimes you can also bruise that too if you land just right, if you fall. So it's the very lowest, most inferior part of the vertebral column. It's made of 4 fused vertebrae. Okay, so moving on, now we're at the thoracic cage. So this is also called your rib cage. So it's made of your thoracic vertebrae. They're actually considered part of 2 different regions of the skeleton. All the ribs, the sternum, what we call your breastbone, and then your costal cartilages. So those are the rib cartilages, the cartilage that attach the rib bone in the front to the sternum. And the thoracic cage, it supports your pectoral girdle, which is your scapula and your clavicle. Those are your shoulder bones, basically. And also your upper limbs. So the thoracic cage is how you attach your arms. Upper limb is the appropriate way to say arms, scientifically. But also it protects your third most important set of organs, the viscera. That's another word for organs. So your heart and your lungs. You kind of need those to stay alive too, just like you need your brain and your spinal cord. And also this plays a role in breathing. You have muscles that run through and around those rib bones, and those are what expand and contract your chest so that you can breathe. And this is also why if you ever bruise a rib or break a rib, it takes such an incredibly long time to heal, because if you break your arm, you put a cast on and you don't move it for 6 weeks, but you can't do that with your ribs. If you put a cast on your chest so that you can't expand it or move it, you will die because you can't breathe. So healing here, if you were to injure one of these, just takes an incredibly long time, and it's fairly painful. So for the ribs, these are actually broken down into further subcategories. So humans have 12 pairs of ribs. All humans, unless you have a birth defect or you had a surgery or an injury, all humans have 12 pairs, so 24 total. There's a myth out there that ladies or that men have one less rib, but that's not true. Okay. The ribs posteriorly, they attach to the thoracic vertebra and they make a joint there. The top 7 ribs, the most superior, these are called true ribs because each rib attaches directly to the rib cage, or excuse me, to the sternum with a costal cartilage. Let me find a picture. So if you look here on the picture, so here's the true ribs, there's 7. So if you look, the costal cartilage goes right to the sternum, like it's a 1-to-1 ratio. Versus the false ribs down here, these all kind of share a costal cartilage. And then the very bottom, the 2 floating rib pairs, they don't have a cartilage at all. And sometimes you can kind of feel these if you kind of feel around on the lower end of your chest. They're kind of wiggly. They don't attach to anything. These ones are easier to break. They're a little bit less well protected. Okay, so you have 7 pairs of true ribs. Then you have 5 pairs of false ribs. 7 and 5 is the 12. But under the false ribs, the last 2 are called floating. Okay. And then these are a flat bone. They're curved, kind of flat. And they all articulate with the thoracic vertebra, but only some of them directly articulate with the sternum. Here's the sternum. So the sternum is also commonly called the breastbone. If at Thanksgiving you did the wishbone, that is the sternum of a bird. It looks very different from our sternum. Ours is not Y-shaped like that. Our sternum looks like this. It's here in the middle. This whole thing is the sternum. In birds, they have an exaggerated manubrium at the top here, and it kind of Y's out, but the body of theirs is much smaller. And that's so that it can provide attachment for pectoral muscles because birds fly. We don't, so ours is not shaped in that manner, but it's the same bone as the wishbone. Okay, and it does have the 3 parts. So the top part I mentioned is called the manubrium. You should know that. And the middle part, where you can kind of like touch more, like if you put your hand in the middle of your chest, that's called the body, middle body. At the very bottom is called the xiphoid process. It starts with an X, but you pronounce it with a Z sound, xiphoid. And you can kind of feel the xiphoid process at the bottom. If you have a pet, sometimes they jump on it and it kind of hurts. Okay, and the sternum, in addition to making a joint, what we call articulating, making a joint with the ribs, the sternum also articulates with the clavicles, which are your collarbone, to help, your arms have movement. Oh, and that is the end of the notes.